Hi, I'm Michelle Cullen, and this is a recap for week 2, things that I want you to learn. Well, you did a lot in this short week, from creating your first entry to your Constellation of the Week field guide project, to learning about some ancient astronomy and astrology. You should be familiar with how different cultures have observed the night sky and wove their observations into creation myths. You probably learned that most ancients used the stars and the sun as a way to keep track of the seasons and time. In other words, the rising and setting of suns and moons were a calendar for ancients. The Polynesians learned how to navigate the ocean by the stars, and other cultures used the stars to aid in the timing of religious and ceremonial aspects from their culture. The ancient Greeks also used math and calculations to be able to predict the circumference of the Earth fairly accurately. Hipparchus, the greatest ancient astronomer, calculated that the Earth wobbled in a cycle we called precession, and he also came up with a relative ranking of how order of brightness of the stars. Ptolemy's geocentric or Earth-centric model of the solar system mapped the celestial sphere and had the planets circling around the Earth in complicated epicycles. In fact, Ptolemy was able to predict the motion of the planets across the night sky and predict where they would be at any day of the year. So his geocentric model persisted for more than 1,500 years. Was it right? No. He was able to get it to work to do the calculations. Many ancient civilizations made detailed observations about the stars, moon, and planets, yet most of the use of their data was to understand the action of the gods who they believed lived in and among the heavens. As the OpenStax astronomy book, section 2.3 talks about, before the time of our scientific perspectives, everything that happened in nature, from the weather to diseases and accidents to celestial surprises such as eclipses or new comets, was thought to be an expression of the whims or displeasures of the gods. Any signs that helped people understand what these gods had in mind were considered extremely important. So I see this as a motivation for much of ancient astronomy. As a matter of fact, the Greeks named their planets after their gods, and they believed that the movement of the wanderers, or the planets, had the same power to influence people's lives, and hence the ancient system of astrology was born. The modern science of astronomy had to wait for giants like Kepler, Galileo, and Newton with the start of the scientific revolution in the 1600s. This week, we looked at the scale model of the universe and just put it in perspective. We now know that the Earth is not the center of the universe, but instead, we live on a planet that orbits an ordinary star in the Milky Way galaxy, with over 100 billion other stars in our galaxy alone around in our galaxy. Our solar system is about 2/3 of the way out of a spiral arm in the Milky Way, and we orbit the center of the galaxy on our little solar system's arm once every 230 million years. Now, our Milky Way galaxy is one of 40 other galaxies clustered in a local group, and this is part of a local supercluster. And we know that the observable universe contains roughly 100 billion galaxies. So we have vast numbers of galaxies, of solar systems, and suns. We also have vast distances. These cosmic distances are hard to comprehend because they're so big, but we can get a little bit of perspective with the scales of 10 video, and we'll learn to use with this semester the astronomical unit. It's abbreviated AU, and it's the distance from the sun to the Earth. And that 150 million kilometers, or 1 AU, is a very handy unit of measure for solar system astronomy. The light year is the distance that light travels in 1 year, and while it's a very large distance, it's not very practical for the solar system alone. It's more helpful for when we look at how far our nearest star would be, or other galaxies. Our universe started with the Big Bang 14 billion years ago, and our solar system formed the elements that are made out of recycled star stuff that came from the explosion of stars and reformation of new stars. Our solar system started 4.5 billion years ago. And our lifetimes, in comparison to that very large number, 4.5 billion, are a very small fraction. When we put the cosmic calendar to use, we compress the history of the universe into 1 year, and we can see that the human lifetime is only a fraction of a second on this scale. Well, I hope you enjoyed this week.